Hello, welcome back to Ali Maths. In this video I'm going to be covering the laws of exponents, which are also known as indices. The aim of this video is for you to understand the parts of an expression with exponents, and to not only know what the laws are, but how they make sense, so it doesn't just seem like a list of rules for you to follow. I will be making a separate video dedicated to covering some example questions, which you'll be able to find by clicking on the icon in the top right corner of your screen once it is released. Remember to like and share this video, subscribe to my YouTube channel, and leave a comment with any feedback or requests for topics or questions. There are three main parts to an expression with exponents in it, which I've labeled A, X, and N. A, which is the letter or number on the left, is called the coefficient. X here is the base, which is the number or variable which is being raised to another power. N, which is called the exponent or the index, sometimes called the power, is a small number which is to the top right of the base. In the first example, our base is x, our exponent is 2, and there's also a coefficient which is 1. However, you usually don't write a 1 before a variable because it's just assumed to be there. And again, in this next example, our coefficient is 6, the base is a here, and the exponent is 4. One of the most common misconceptions is that 6a to the 4th power means that you take 6a and you multiply that by itself 4 times. However, what it really means is that you're multiplying a to the 4th power by 6. This means that the coefficient is multiplied after the base has been raised to the exponent. In our final example here, we're given the expression 3x cubed. If we let x equal 2, first we evaluate 2 cubed, which is 8, and then we multiply that by 3 to get our final answer of 24. We don't multiply 3 times 2 and then cube that because that gives us a totally different answer. Our first indice law is about multiplying indices. So if you raise some base a to a power m and you multiply that by that same base raised to another power n, your result is a raised to m plus n. Notice that both bases have to be same for this rule to be true. For example here, if we have 2 raised to the 4th power multiplied by 2 cubed, our answer is 2 raised to 4 plus 3, which is 2 to the 7th. This actually makes quite a lot of sense when you think about it, because 2 to the 4th power can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2 4 times. And then 2 cubed can be written again as 2 multiplied by 2 multiplied by 2 3 times. So now if you count all of the 2's you have in total, you've got 7 2's. So you can write that as 2 to the 7th power. Now if we think back to our original expression, using variables to denote our bases and exponents, we've got a times a times a, and then we've got an m number of a's, multiplied by a multiplied by a multiplied by a, with another n number of a's. And when you take all of that together, multiplied together, you would get m plus n number of a's, which would equal a raised to the m plus n power. Our second rule is about dividing exponents. So if you raise a to some power n, and divide that by a raised to some power n, your answer will be a raised to m minus n. Now in this example using 2's, if we have 2 raised to the 4th power divided by 2 raised to the 3rd power, that's just equal to 2 raised to 4 minus 3, which is 2 to the 1st power, which we can just write as 2. We can rewrite 2 to the 4th power as 2 times 2 times 2 times 2, 4 times. And then we can rewrite 2 cubed as 2 times 2 times 2 with 3 2's. However, the 2's on the top and bottom can cancel out. So this 2 can cancel out that 2. This 2 cancel out this one. And this can cancel out this one. So we're left with just 1 at the bottom, because we've cancelled all those out, and a 2 at the top. So then 2 divided by 1 is equal to 2. So that's how we get our answer. Using our variables again, the excess number of m a's on the top will be cancelled out by the number of n a's on the bottom to leave us with a raised to m minus n. However, if there are more a's on the bottom, or if n is bigger than m, that means we'll be dealing with negative powers, which we'll encounter in another rule later on. The third exponent law is about raising an exponent to another exponent. Here, this means that when you have a base a raised to the power m, then you raise all of that to the power n, your answer is a to the power of m times n. If we have 2 to the power of 4, and then we cube all of that, that's equal to 2 to the power of 4 times 3, which is equal to 2 to the power of 12. We can show that this is true by rewriting 2 to the power of 4 cubed as 2 to the power of 4 times 2 to the power of 4 times 2 to the power of 4. We write this 3 times because it's raised to the power of 3. Thinking back to our first rule, when we multiply powers which have the same base, we add them together. So here, we just add up the powers 4, 4, and 4, so we end up with 2 to the power of 12 as our answer. The final law of this video states that if you have an expression AB inside the brackets and you raise all of that to the power m, your answer is equal to a to the m multiplied by b to the m. This can be shown in a similar way to the last rule. If you have an expression AB cubed, then that's equal to AB multiplied by AB multiplied by AB with 3 ABs. This in turn can be rewritten as a times b for the first one, then another a times b, and another a times b. Finally, since we've got 3 a's and 3 b's, we can write this as a cubed times b cubed, which follows our rule. This rule crops up quite often in most problems involving indices. For example, in this question, we've got 3x raised to the power of 4. So this is equal to 3 raised to the power of 4 multiplied by x to the power of 4. 3 raised to the power of 4 is 81, and then we can write that as 81x to the power of 4. This concludes my first video on the exponent laws, with the rest covered in my next video. Remember to subscribe with post notifications turned on so you never miss a future upload. Thank you so much for watching.